Sometimes a question isn't meant to have an answer. It exists to find the cracks in the code of the universe, to pull at the very edges of what you call reality. These aren't just riddles, they are the raw, violent collisions between pure logic and a cosmos that refuses to play by the rules. And somehow, they have survived every attempt to be solved. This is not a list of curiosities. It is a descent into the deepest tensions in science, the places where our most brilliant ideas shatter. You will encounter time loops that feed themselves, existing without ever being created. Civilizations that the math screams should be everywhere, yet are nowhere to be found. And you will confront the terrifying moment when looking at something changes what it is. You'll meet cats suspended between life and death, billiard balls that travel back in time to stop themselves, and black holes that are not just destroying matter, but actively erasing the past. Each paradox begins with a simple, almost elegant idea. But when you follow it to its logical conclusion, reality breaks. And that's where the truth begins.
If you are someone who finds a strange beauty in not having all the answers, who doesn't mind the feeling of vertigo from staring into the unknown, then you are in the right place. Subscribe to Late Science. Like this video if you learn something that leaves a crack in your certainty. And leave a comment with the one idea you cannot shake. Because the universe isn't a story. It's a layered, unstable, and occasionally impossible machine. And maybe, just maybe, the paradoxes aren't the flaw, they're the point. Space looks peaceful, but it hides a question that is screaming at us in its silence. We live in a galaxy with hundreds of billions of stars, most of them with billions of years of a head start on us. We now know, as a fact, that planets are not the exception, but the rule. A shocking number of them are like our own Earth, warm enough for water, stable enough for life, and old enough for something intelligent to have awakened. So, where is everyone? We have been listening, with giant radio telescopes, mechanical ears pressed against the cosmos. We have scanned the sky for decades. We are searching for a single whisper, a coded signal, anything artificial in the cosmic static. But all we have found is silence, a deep, profound, and constant silence. It's as if we are shouting into a cosmic void and hearing nothing back. Not because no one is there, but because maybe something else is going on. The math screams that we shouldn't be alone. The numbers are undeniable. Intelligent life should have emerged countless times in countless places. Even with the most pessimistic assumptions, there should be thousands of civilizations in our galaxy right now. And yet, there is not a single verified signal, not one undeniable trace. Just stars, just the crushing weight of distance. This contradiction has a name, the Fermi paradox, but it doesn't need one to be felt. It's the question that finds you late at night when you're looking out a window and the sheer scale of the sky hits you. It dismantles our deepest beliefs, that life naturally leads to technology, that intelligence always seeks to communicate, that progress is an inevitable arrow pointing up. Maybe civilizations destroy themselves before they can ever reach the stars. Maybe they rise and fall in the blink of a cosmic eye, too fast to be noticed. Or maybe, and this is a colder thought, they are out there right now, watching us and choosing to remain hidden. There is another possibility, one that sits heavier than all the rest. Maybe we are the first. That idea changes everything. It transforms humanity from one voice in a potential chorus to a fragile, precious, and terrifyingly unique event. It means we aren't just searching for others. We are carrying a torch that may not exist anywhere else in this galaxy. A chance to speak into a silence that has never been broken. A responsibility not to let our own light go out before anyone else has a chance to see it. If that thought makes the stars feel colder or the silence feel heavier, you are not alone. Subscribe to Late Science. There are more questions waiting, and none of them come with easy answers. Because when the sky stays quiet for this long, it stops feeling empty. It starts to feel deliberate. Not long ago, Earth was a fragile blue dot orbiting a modest star, the only known place with the ingredients for life. We believed we were unique, and in that, we found comfort. But that illusion has been shattered. Modern telescopes have shown us that our galaxy is overflowing with planets, hundreds of billions of them, and among them, worlds like our own are not rare. They are terrifyingly common.
The Kepler mission confirmed it. Across the Milky Way, there may be over 300 million rocky planets in the habitable zones of sun-like stars. Not one or two, hundreds of millions. Worlds with the potential for oceans. Worlds bathed in sunlight. Worlds with the gift of deep time. Even if a tiny fraction of those ever sparked biology, and a tinier fraction of that sparked consciousness, we should be drowning in their signals. We should see the flicker of their communications, the traces of their megastructures, the artifacts of their passage. But the sky is dead quiet. This isn't a poetic silence, it's a sharp mathematical contradiction, the kind of equation that breaks your sense of scale. Because space isn't just big, it's ancient. Some of these potential worlds orbit stars that are billions of years older than our sun. That is more than enough time for life to evolve, build star-spanning civilizations, and leave its mark. If it happened even once, in even one place, why do we see nothing? It starts to feel like walking into a vast, ancient cathedral and realizing you are the only one breathing. The air should be thick with the echoes of voices, of footsteps, of history. Instead, it is pristine. It is empty. And the more you learn about how full this place should be, the more unnatural that emptiness feels. There are theories, of course. Maybe intelligence is a fatal mutation. Maybe they hide from something we can't see. Maybe the distances are simply too vast. But every explanation feels like an excuse. A story we tell ourselves to make the silence bearable. Every answer only leads to a harder question. Why does it feel like we arrived late to a party that never even began? If the thought of hundreds of millions of silent Earths makes our own existence feel more fragile or more precious, like the video and subscribe to Late Science. We are just beginning to count the things we cannot explain. And if there are millions of worlds out there with life, why is ours the only one that feels watched? Some problems don't arise from a lack of information, but from a surplus of logic. The kind of logic that leads you, with perfect reasoning, straight into a brick wall. That's what happened in 1961, when an astronomer tried to cage this terrifying mystery in the form of an equation. The Drake equation wasn't meant to be solved. It was meant to be a loaded gun pointed at our certainty. It lays out the variables. How many stars are born each year? How many have planets? How many of those planets can support life? Of those, how many actually do? How many of those life forms evolve intelligence? How many build technology that screams their presence across the stars? And the final, brutal variable, how long do they last? Multiply it all together and you get a number that should tell you how many alien civilizations are broadcasting into our galaxy right now. And here is the part that never fits.
No matter how brutally conservative your estimates, the answer is almost never zero. The equation suggests we should be surrounded, that the radio spectrum should be a cacophony of alien languages, whispers in every direction, signals coded in pulses, in patterns, in artificial, intelligent echoes. But again, silence. So we go back to the formula. We twist the knobs. Maybe life is a 1 in a trillion miracle. Maybe intelligence is a cosmic fluke. Maybe technology is impossibly rare. Or maybe the last variable, the lifespan of a civilization, is a graveyard. Maybe that number is so small, so fleeting, that everything else becomes irrelevant. There are two ways to explain the silence. One is terrifying, the other is worse. The first imagines the galaxy not as empty, but as a place full of silent watchers. Civilizations far older and more intelligent than us, scattered across the stars, but every single one of them is hiding, listening, waiting. And they are terrified of being found, not because they are paranoid, but because they know something we do not. This is the dark forest theory. In this universe, every species is a hunter, and every planet is a hiding place. The moment you reveal your location with a message, a light, a signal, you become the prey. Because in a cosmos where you cannot know the intentions of what is out there, the only winning move is to stay silent. And when something else makes a sound, you eliminate it. That would explain why we've heard nothing. The others are out there, but they are not speaking. They are watching us, wondering if we are smart enough to stay quiet or foolish enough to shout into the dark. It is a grim theory, but it fits the data perfectly. No signals, no contact, just an endless field of stars, all holding their breath. Then there is the other possibility, that there is nothing out there at all. Not because it's hiding, not because it's dangerous, but because we are utterly and completely alone. This is the empty ocean, vast, silent, not because it is being quiet, but because there is simply no one else in the water. We are the first to build a boat, or the only ones who ever will.
Both ideas explain the silence. Both are deeply unsettling. Because if the galaxy is a forest full of eyes, we are being watched. And if it is an empty ocean, then we are it. The lone witness, the last hope. The species that, if it fails, leaves nothing behind but more silence. So we go on listening, and we wonder what kind of galaxy we truly live in. A forest full of unseen threats, or a sea too vast for any voice to carry? If either of those images sent a chill down your spine, subscribe to Late Science. This is only the first layer. We haven't even begun to ask the hardest questions. And maybe the scariest thing isn't that the others are silent, it's that they were never there to begin with. We used to think we were at the center of everything. Then we learned the Earth orbits the Sun, that the Sun is just one of billions of stars, that our galaxy is one of trillions. With every step, we became smaller. And still, somehow, we assumed we couldn't be alone. But the silence is starting to change that. It is not just that we haven't found intelligent life. It is that we keep discovering more and more reasons why we should have. More habitable planets, more time, more tools, more chances. And yet the universe stays quiet. It is not whispering. It is not murmuring. It is absolutely, overwhelmingly mute. There's a strange emotion that settles in with that realization. Not fear, exactly, and not wonder. It is a kind of cosmic loneliness, a sense that the vastness out there is real and no one else is watching it with us. But maybe silence does not mean emptiness. Maybe it means fragility. If life is this rare, then we are holding something irreplaceable. If intelligence doesn't last, then we are a brief flicker in an eternal darkness, a flicker that could go out just as easily as it appeared.
And if we are the first, then we are more than just observers. We are the experiment, the first voice in the void. And that means we don't just get to ask where the others are. We have to ask what kind of story we want to leave behind. What kind of legacy are we building or failing to build for the next travelers who might one day find what we've left? Maybe that is what makes this silence so heavy. It reflects everything back at us. We don't hear aliens because maybe, just maybe, we are supposed to be hearing ourselves. A warning, a chance, a responsibility. If the idea that we are the only conscious eyes looking out into the cosmos makes you feel a little smaller or a little more awake, hit subscribe to Late Science. This is where awe and fear live side by side. Because in a galaxy that should be full of noise, silence is the one sound you don't expect. And sometimes, silence is the loudest answer of all. Time feels like the most stable thing we know. It ticks forward, a relentless, unbreakable arrow. Seconds become days. A cause always precedes an effect. And yet there is a strange fracture hiding beneath this rhythm, a possibility that time may not just move, it may circle. It may trap you. That's where the next problem begins. Imagine a loop. Not a metaphor, not poetry, a literal, physical loop in time. You take something from the future, bring it to the past, and that thing becomes the very reason it exists in the first place. There is no beginning, no creation, just an endless, self-sustaining cycle with no origin point. A story that is its own author. This is the foundation of one of the most unnerving contradictions in physics, the bootstrap paradox. The kind that doesn't just challenge what's possible, but what existence even means. Picture this. You walk into a bookstore and buy a worn copy of Hamlet. Later, you build a time machine. You travel back to Shakespeare's London, and for the sake of the experiment, you hand him the book. He reads it, is struck by its genius, copies it, and publishes it under his own name. Centuries later, that exact copy ends up in the same bookstore you walked into. Who wrote Hamlet? It didn't come from nowhere, but it didn't come from anywhere either. This is the bootstrap paradox. It is a cycle where the effect is its own cause, an object or a piece of information that exists in time but was never created. It exists simply because the loop itself exists. And while this sounds like a thought experiment for philosophers, it is something that Einstein's theory of general relativity does not rule out. In fact, his equations allow for closed time-like curves, paths through space-time that circle back on themselves. Under the right conditions, near a spinning black hole or through a hypothetical wormhole, you could travel into your own past and deliver the book. It is not just a strange idea, it is destabilizing. Because if time can do this, if information can exist without a source, then nothing is truly original. Not ideas, not inventions, not even you. If the rules of time can be bent into a circle, then reality is less like a straight road and more like a spiral staircase. You keep moving, but every so often you pass the same point again, and this time, you're the one holding the book. If this made time feel less like a clock and more like a prison, subscribe to Late Science. Because the deeper we go, the more time begins to fold in on itself. And maybe what we think of as the beginning is just the middle of the loop. You hand the book to Shakespeare. He reads it, memorizes it, and publishes it as his own. Hamlet becomes a masterpiece, passed through generations, taught in schools, printed, performed, worshipped. Centuries later, you walk into a bookstore and pick up the same copy. You take it back in time. The loop closes. No one wrote it. This is the heart of the problem. Not just an object with no origin, but information that sustains itself through time without ever being created. There was no flash of inspiration, no author with a quill, no mind behind the words. The story simply exists because it always has, because it never didn't. And this breaks something fundamental. We build our world on the assumption that everything has a source. Thoughts come from minds, machines come from inventors, music comes from composers. But in this loop, the source vanishes, and yet the thing remains. It makes you wonder what else could exist this way. A scientific formula, a technological blueprint, a piece of knowledge that appears in one mind and is passed into the past only to return in the future unchanged. A perfect circle, like a song with no composer, playing endlessly on repeat. Physics doesn't dismiss this. Einstein's theory of relativity doesn't forbid time loops. In fact, certain solutions, especially involving extreme gravity or hypothetical constructs like wormholes, allow for scenarios where the past and future intersect. And that opens the door to self-created objects, self-initiated events, and cause and effect dissolving into one continuous ribbon. It also opens something darker. What if we are part of such a loop? What if an idea, a piece of our own civilization, a technology, a belief, didn't originate here or now or from us? What if we are just carrying the torch from a future that already knew what we would do? If time allows loops like this, then invention becomes memory, and history becomes rehearsal. If that makes you question the origin of the thoughts you're thinking right now, subscribe to Late Science. We are not just moving forward, we might be circling something we've already seen. And maybe there are things in this world that exist only because they never didn't. Think of time as a sheet of paper, flat, linear, clean. You can draw a straight line from the past to the present and extend it toward the future. It is smooth and sensible. But what if that paper folds? What if 2 points that should be years apart suddenly touch? That is what happens in a closed time-like curve. An object doesn't just move through time, it escapes the timeline. It bends it. It connects the end to the beginning. Like a crease in the fabric of the universe, a fold that makes yesterday and tomorrow neighbors. It sounds abstract, but this is what some solutions to Einstein's equations suggest is possible. Near rotating black holes, or through hypothetical wormholes, time doesn't have to flow in one direction. It can circle. It can collapse in on itself. It can, in theory, be folded like origami. And when that happens, strange things start to happen. You place a violin into a time machine and send it backward. A composer in the past discovers it, creates music with it, and that music becomes famous. The violin is preserved, passed through generations, until one day you find it and send it back again. There was no original craftsman, no moment of creation, just a loop. A shape folded perfectly on itself. These loops are self-consistent. They do not break the timeline, they preserve it. As long as the events within the loop do not contradict each other, the loop can continue forever. Nothing needs to be explained because the explanation is the loop itself.
But this elegance hides something deeply strange. Because if time can fold like this, then what is memory? What is invention? What is the difference between discovering something and being handed it from a future you haven't lived yet? Maybe this isn't fiction. Maybe something you believe, something you've read or thought or built is not original at all. Maybe you are just one fold in the paper, one crease on the map, and the idea was already traveling back to you. It changes how we see progress. Maybe we don't build ideas, we receive them. Maybe we are not inventors, we are couriers. And if time can fold like this, how many folds are we standing on right now?
without even noticing. If that made you glance at your own thoughts a little differently, hit subscribe to Early Science. What looks like a straight line may turn out to be the edge of a spiral, because sometimes time doesn't move forward. Sometimes it folds and hands you something it hasn't made yet. Some systems can break with too much information. Stand too close to a speaker while holding a microphone and you'll hear it, that rising screech, the howl of a loop forming. Sound enters, gets amplified, re-enters, and builds until the system collapses under its own echo. Now, imagine reality doing something similar. In certain models of time, events can form feedback loops, not because something is repeated, but because an effect becomes its own cause. The future reaches back, feeds into the past, and together they generate the present. It's not a story told in order, it's a circuit. Think of a physicist who receives the final form of a revolutionary equation from her future self. She studies it, understands it, publishes it, and eventually becomes the one who sends it back. The knowledge exists, it's useful, but where did it come from? The loop feeds itself. No contradictions, no inconsistencies, just a clean, recursive chain, a stable paradox. And this kind of logic is being taken seriously, especially in the world of quantum mechanics. Some researchers believe information in our universe may not always flow in a straight line, that the past, present, and future can become entangled, with effects being determined by future measurements. Systems that only become what they are after they're observed. Events that only occur if the timeline stays intact. It's called post-selection, and it breaks everything we thought we knew about causality. These loops aren't accidents, they're constraints. Nature, some believe, only allows realities that fit together perfectly. Inconsistent stories are discarded. Universes that don't make logical sense, where paradoxes explode, never stabilize. Only self-consistent histories survive.
The paradox is the only thing that brings truth to light. Niels Spohr. Sometimes a question isn't meant to be answered. It exists to shake the ground beneath your certainty, to pull at the edges of what you think reality is. These aren't riddles or tricks of language. They're the raw collisions between logic and the universe, and somehow they've survived every attempt to resolve them. This video is not just a list of curiosities. It's a journey into the deepest tensions in science, the places where our best ideas stop working. You'll encounter time loops that close without ever opening, civilizations that should be everywhere yet remain unseen, and moments when observing something actually changes what it is. You'll meet cats that are both alive and dead, billiard balls that collide with themselves, and black holes that may be erasing history. Each concept begins with something simple, but the moment you follow it to its logical end, something breaks, and that's where it gets interesting. If you're someone who finds beauty in not having all the answers, who doesn't mind staring into the unknown a little too long, then you're in the right place. Subscribe to Early Science, like the video if you learned something that unsettles you, and leave a comment with the one idea you just can't stop thinking about. Because the universe isn't neat, it's layered, unstable, occasionally impossible, and maybe, just maybe, that's the point.
Space looks calm, but it hides a question that's anything but peaceful. We live in a galaxy with hundreds of billions of stars, most of them older than our sun. We now know that many of those stars have planets, and a surprising number of those planets might have conditions similar to Earth. Warm enough for water, stable enough for life, old enough for something intelligent to have emerged. So where is everyone? We've been listening carefully, patiently. Giant radio telescopes have scanned the sky for decades, hoping to catch a whisper, a signal, anything artificial. But what we found is silence. Deep, constant silence, as if we're shouting across a canyon, and hearing nothing back. Not because no one's there, but because maybe something else is going on. Statistically, we shouldn't be alone. The numbers suggest that intelligent life should have appeared many times in many places. Even with cautious assumptions, there should be hundreds, maybe thousands of civilizations in our galaxy alone. And yet, not a single verified signal. Not a single undeniable trace. Just stars. Just distance. This contradiction has a name, but it doesn't need one to be felt. It's the kind of question that settles in late at night when you're staring out a window and realizing how much sky is really out there. It challenges the belief that life leads naturally to technology, that intelligence leads to communication, that progress is guaranteed. Maybe civilizations rise and fall too quickly to be noticed. Maybe they destroy themselves before they ever get the chance to reach beyond their home. Or maybe they're out there right now, watching quietly, choosing not to be seen. There's another possibility, one that sits heavier than the rest. Maybe we really are the first. That idea changes everything. It makes humanity something fragile, something rare. Means we're not just searching for others, we're carrying something that might not exist anywhere else. A chance to speak when no one has spoken. A responsibility not to vanish before we're heard. If that thought makes the stars feel colder or the silence feel heavier, you're not alone. Subscribe to Early Science. There are more questions waiting, and none of them come with answers. Because when the sky remains quiet for this long, it stops feeling empty. It starts to feel deliberate.
Not long ago, Earth was the only known planet with the right ingredients for life. A fragile blue dot orbiting a modest star, unique and alone. But that illusion shattered. Thanks to modern telescopes and sky surveys, we now know our galaxy is overflowing with planets, hundreds of billions of them. And among them, Earth-like worlds are not rare, they're common. Data from the Kepler mission confirmed it. Across the Milky Way, there may be over 300 million rocky planets orbiting sun-like stars in the so-called habitable zone. Not one or two, hundreds of millions. Worlds with oceans, worlds with sunlight, worlds with time. Even if a tiny fraction of those ever gave rise to biology, and an even smaller number to consciousness, we should be seeing signs, flickers of communication, traces of machinery, artifacts that say someone else passed through here, but the sky remains quiet. This isn't a poetic silence, it's a sharp contradiction, the kind of math that breaks your sense of scale. Because space isn't just big, it's old. Some of these stars are billions of years older than our sun. That's more than enough time for life to evolve, build civilizations, and reach across the stars. If it ever happened even once, in even one place, why do we see nothing? It starts to feel like walking into a vast cathedral and realizing you're the only one breathing. The air should be full of voices, echoes, footsteps. Instead, it's empty. And the more you learn about how full the universe should be, the more unnatural that emptiness feels. There are theories, of course. Maybe intelligent life doesn't last long. Maybe it hides. Maybe it's spread out so thin that we'll never find each other. But every explanation comes with its own problem. Every answer leads to another question. Why does it seem like we arrived late to a party that never happened? If thinking about hundreds of millions of Earths with no reply makes your own existence feel more fragile or more precious, like the video and subscribe to Early Science, because we're just beginning to count the things we can't explain. And if there are millions of worlds out there with life, why is ours the only one that feels watched?
Some problems don't come from a lack of information, but from too much logic. The kind that leads you straight into a wall. That's what happened in 1961, when an astronomer tried to turn a mystery into a formula. The equation wasn't meant to solve anything, just to lay out the variables. How many stars form each year? How many have planets? How many of those planets can support life? Of those, how many actually develop it? How many forms of life evolve intelligence? How many intelligent beings build technology that can be detected across the stars? And how long do those civilizations survive? Multiply it all together and you get an estimate, a number, something that tells you how many alien civilizations should be broadcasting through our galaxy right now. And here's the part that never quite fits. No matter how conservative the inputs, the answer usually isn't zero. The Drake equation suggests we should be surrounded, that radio waves should be washing over us, whispers in every direction, signals coded in pulses, patterns, artificial echoes. But again, silence. So we go back to the formula, try to make sense of it. Maybe we were too generous. Maybe life doesn't evolve easily. Maybe intelligent life is rare. Maybe technological life is rare. Or maybe the last variable, the lifespan of a civilization, is where everything collapses. How long do we last?
There are two ways to explain the silence. One is terrifying. The other is worse. The first imagines the galaxy not as a void, but as a place full of watchers. Civilizations vast and intelligent, scattered across the stars, but each one hiding, listening, waiting, and terrified to be found. Not because they're paranoid, but because they've learned something we haven't. This idea paints the universe as a dark forest. Every species is a hunter, every planet a hiding place. The moment you reveal yourself, a message, a light, a signature, you become a target. Because in a place where you don't know who or what is out there, the safest strategy is silence. And when something makes a sound, it disappears. That would explain why we haven't heard anything. Maybe the others are out there, but they're not speaking. They're watching us, wondering if we're smart enough to stay quiet or foolish enough to shout into the dark. It's a grim theory, but it matches the facts. No signals, no contact, just an endless field of stars, all seemingly mute. Then there's the other possibility, that there's nothing out there at all. Not because it's hiding, not because it's dangerous, but because we're alone. This is the empty ocean, vast, silent. Not because it's being quiet, but because there's simply no one else in the water. We may be the first to sail this far, or the only ones who ever learned to build a boat. Both ideas explain the silence. Both are deeply unsettling. Because if the galaxy is full of eyes, we're being watched. And if it's empty, we're it. The lone witness, the last hope. The species that, if it fails, leaves nothing behind. So we go on listening, and we wonder what kind of galaxy we live in. A forest full of threats, or a sea too big for voices to carry? If either image sent a chill through your spine, subscribe to Early Science. This is only the first layer. We haven't even asked the hardest questions yet. And maybe the scariest thing isn't that the others are silent. It's that they were never there to begin with.
We used to think we were at the center of everything. Then we learned the Earth orbited the Sun, that the Sun was just one of billions of stars, that our galaxy was one of trillions, and still, somehow, we assumed we couldn't be alone. But the silence is starting to change that. It's not just that we haven't found intelligent life, it's that we keep discovering more reasons why we should have. More habitable planets, more time, more tools, more chances. And yet, the universe stays quiet. It's not whispering,
It's not murmuring. It's absolutely, overwhelmingly mute. There's a strange emotion that comes with that. Not fear, exactly, and not wonder either. It's a kind of cosmic loneliness, a sense that the vastness out there is real and no one else is watching it with us. But maybe silence doesn't mean emptiness. Maybe it means fragility. If life is rare, we might be holding something irreplaceable. If intelligence doesn't last, we may be a flicker in the dark, one that could go out just as easily as it appeared. And if we are the first, then we're more than observers. We're the experiment, the first voice in the void. And that means we don't just get to ask where the others are. We have to ask what kind of story we want to leave behind, what kind of legacy we're building or failing to build for the next travelers who might someday find what we've left. Maybe that's what makes this silence so heavy. It reflects everything back at us. We don't hear aliens because maybe we're supposed to hear ourselves. A warning, a chance, a responsibility. If the idea that we're the only conscious eyes looking out into the cosmos makes you feel a little smaller or a little more awake, hit subscribe to Early Science. This is where awe and fear live side by side. Because in a galaxy full of noise, silence is the one sound you don't expect. And sometimes, silence is the loudest answer of all.
Time feels like the most stable thing we know. It ticks forward, never back. Seconds pass, days end. A cause leads to an effect. And yet there's a strange fracture hiding under this rhythm. A possibility that time may not just move, it may circle. That's where the next problem begins. Imagine a loop, not a metaphor, not poetry, a literal loop in time. You take something from the future, bring it to the past, and that thing ends up becoming the very reason it exists. There's no beginning, no creation, just an endless cycle with no origin point, a story that keeps telling itself. This is the foundation of one of the most unnerving contradictions in physics, the kind that doesn't just challenge what's possible, but what existence even means. Picture this. You walk into a bookstore and buy a copy of Hamlet. Later, you build a time machine. Just for fun, you go back in time all the way to Shakespeare's London and hand him the book. He reads it, likes it, puts his name on it, and centuries later, that exact copy ends up in the same bookstore, the one you walked into. Who wrote it? It didn't come from nowhere, but it didn't come from anywhere either. This kind of loop has a name, but names don't make it easier to digest. It's a cycle where the cause is the effect, and the effect is the cause. A piece of information or an object that exists in time, but not because it was created, just because the loop never breaks. And while this sounds like a writer's thought experiment, it's something general relativity doesn't rule out. In fact, Einstein's equations allow for closed time-like curves, paths through space-time that circle back on themselves. Under certain conditions, you could travel to your own past and bring something with you. It's not just strange, it's destabilizing. Because if time can do that, if loops like this are real, then nothing is truly original. Not ideas, not inventions, not even you. If the rules of time can circle around like this, then reality is less like a straight road and more like a spiral staircase. You keep climbing, but every so often you pass the same point again, and this time, you're the one holding the book. If this made time feel less like a clock and more like a trap, subscribe to Early Science, because the deeper we go, the more time starts to fold in on itself, and maybe what we think of as the beginning is just the middle of the loop. You hand the book to Shakespeare. He reads it, memorizes it, and publishes it as his own. Hamlet becomes a masterpiece, passed through generations, taught in schools, printed, performed, worshipped. Centuries later, you walk into a bookstore and pick up the same copy.
You take it back in time. The loop closes. No one wrote it. This is the heart of the problem. Not just an object with no origin, but information that sustains itself through time without ever being created. There was no flash of inspiration, no author with a quill, no mind behind the words. The story simply exists because it always has, because it never didn't. And this breaks something fundamental. We build our world on the assumption that everything has a source. Thoughts come from minds. Machines come from inventors. Music comes from composers. But in this loop, the source vanishes. And yet the thing remains. It makes you wonder what else could exist this way. A scientific formula, a technological blueprint, a piece of knowledge that appears in one mind and is passed into the past only to return in the future unchanged. A perfect circle, like a song with no composer, playing endlessly on repeat. Physics doesn't dismiss this. Einstein's theory of relativity doesn't forbid time loops. In fact, certain solutions, especially involving extreme gravity or hypothetical constructs like wormholes, allow for scenarios where the past and future intersect. And that opens the door to self-created objects, self-initiated events, cause and effect dissolving into one continuous ribbon. It also opens something darker. What if we're part of such a loop? What if an idea, a piece of our own civilization, a technology, a belief, didn't originate here or now or from us? What if we're just carrying the torch from a future that already knew what we would do? If time allows loops like this, then invention becomes memory, and history becomes rehearsal. If that makes you question the origin of the thoughts you're thinking right now, subscribe to Early Science. We're not just moving forward, we might be circling something we've already seen. And maybe there are things in this world that exist only because they never didn't.
Think of time as paper, flat, linear, clean. You can draw a line from the past to the present and extend it toward the future, smooth and sensible. But what if that paper folds? What if 2 points that should be years apart suddenly touch? That's what happens in a closed time loop. An object doesn't just move through time, it escapes the timeline entirely, bends it, and connects the end to the beginning. Like a crease in the universe, a fold that makes yesterday and tomorrow neighbors. It sounds abstract, but this is what some solutions to Einstein's equations suggest is possible. Near rotating black holes under certain conditions or through hypothetical wormholes, time doesn't have to flow in one direction. It can circle. It can collapse in on itself. It can, in theory, be folded like origami. And when that happens, strange things start to make sense. You place a violin into a time machine and send it backward. A composer in the past discovers it, creates music with it, and that music becomes famous. The violin is preserved, passed through generations, until one day you find it and send it back again. There was no original craftsman, no moment of creation, just a loop, a shape folded perfectly in on itself. These loops are self-consistent. They don't break the timeline. They preserve it as long as the events don't contradict themselves. The loop can continue forever. Nothing needs to be explained, because the explanation is the loop itself. But this elegance hides something deeply strange. Because if time can fold like this, then what is memory? What is invention? What is the difference between discovering something and being handed it from a future you haven't lived yet? Maybe this isn't fiction. Maybe something you believe, something you've read or thought or built, isn't original at all. Maybe you're just one fold in the paper, one crease on the map, and the idea was already traveling back to you. It changes how we see progress. Maybe we don't build ideas, we receive them. Maybe we're not inventors, we're couriers. And if time can fold like this, How many folds are we standing on without even noticing? If that made you glance at your own thoughts a little differently, what looks like a straight line may turn out to be the edge of a spiral. Because sometimes time doesn't move forward. Sometimes it folds and hands you something it hasn't made yet.
Some systems can break with too much information. Stand too close to a speaker while holding a microphone and you'll hear it. That rising screech, the howl of a loop forming. Sound enters, gets amplified, re-enters, and builds until the system collapses under its own echo. Now, imagine reality doing something similar. In certain models of time, events can form feedback loops, not because something is repeated, but because an effect becomes its own cause. The future reaches back, feeds into the past, and together they generate the present. It's not a story told in order, it's a circuit. Think of a physicist who receives the final form of a revolutionary equation from her future self. She studies it, understands it, publishes it, and eventually becomes the one who sends it back. The knowledge exists, it's useful, but where did it come from? The loop feeds itself. No contradictions, no inconsistencies, just a clean, recursive chain, a stable paradox. And this kind of logic is being taken seriously, especially in the world of quantum mechanics. Some researchers believe information in our universe may not always flow in a straight line, that the past, present, and future can become entangled with effects determined by future measurements. Systems that only become what they are after they're observed. Events that only occur if the timeline stays intact. It's called post-selection, and it breaks everything we thought we knew about causality. These loops aren't accidents, they're constraints. Nature, some believe, only allows realities that fit together perfectly. Inconsistent stories are discarded. Universes that don't make logical sense, where paradoxes explode, never stabilize. Only self-consistent histories survive. That means reality might be editing itself in real time. You're not just experiencing the world forward. You're part of a loop that constantly tests whether your choices, your memories, even your thoughts fit. And if they don't, the loop never forms. That version of you never exists. What emerges is something far stranger than linear time. A feedback-driven cosmos, always echoing, always checking, always curving back on itself. No beginnings, no final cause, just an endless self-sustaining pattern. If that idea turned the arrow of time into a circle in your mind, subscribe to early science. Because what we call reality may be less like a story and more like a closed equation trying to solve itself. And if the universe is listening to itself, maybe that's why we're here, to complete the loop. We think of the past as the foundation, the unmoving bedrock beneath everything. It came first. It caused what's happening now. But what if that's not entirely true? What if the past isn't just the beginning, but the outcome? This isn't imagination. It's a real, unsettling consequence of physics. In some interpretations of quantum mechanics, and even in the way we model certain space-time geometries, the present isn't just shaped by the past, it's also constrained by what the future has to become. Take a quantum system, a particle, that could exist in many states. It's fuzzy, undefined until you measure it. But here's the twist. In certain experiments, the outcome seems to depend not only on how you set things up, but on what you decide to do after the system evolves. The future choice affects the past behavior. This backward influence isn't just a metaphor. It's built into the equations. It's as if the particle was waiting not just to be observed, but to see what kind of future it would end up in, and shaped its history to match. And it doesn't stop with quantum particles. Some physicists propose that even macroscopic systems, like our bodies, our choices, our history, may exist within a larger consistency loop. That the past you remember is only one of many possible ones, the one that best fits the outcome that must exist. In this view, time isn't a single river flowing forward. It's more like a web. The present is a node held in place by threads pulling from both directions. Tug too hard on one side, and the whole thing vibrates.
The future doesn't just emerge from the past. It molds the path that led to it. You can see why this idea doesn't sit comfortably. It pushes us into a world where free will, memory, and even identity are all conditional, where your past wasn't fixed until the future called it into focus. It also means that the universe might not be moving towards something. It might be settling into something, collapsing into a shape where every part agrees with every other part. Cause and effect dissolve into structure. If the past is only real because the future needs it to be, then who exactly are we now? If that made you look back at your own timeline with different eyes, subscribe to Early Science. The most mysterious part of time might not be where it goes, but how it decides what already happened. And maybe what feels like memory is just the echo of what the future couldn't live without.
You build the machine, step inside, type the year. You're going back, not to witness, not to observe, but to act. And the target isn't a king or a tyrant, it's your grandfather. Not out of revenge, just to test the rules. Because if you succeed, if your grandfather dies before your parent is born, then you were never born either. And if you were never born, then you never stepped into the machine. And if you never traveled back, then he lives and you exist. And then you go back, and the knife is in your hand again. This is more than a loop. It's a contradiction folded into reality itself. An action that erases the very possibility of the action, a wound that heals and reopens in the same breath. It's known as the grandfather paradox, but it doesn't just live in fiction. It's one of the biggest threats to the idea that time travel could ever be real. Because if the past can be changed in a way that unravels the present, then the timeline isn't stable. It's fragile, glitch-prone, self-erasing. Physics doesn't like that. So several possibilities emerge. One is brutal in its simplicity. Time travel is impossible, not because it violates logic, but because it creates an unstable system, like a program stuck in an infinite crash reboot cycle. Reality would just fail to load. But there's another idea, something more subtle. Some theories suggest that time protects itself, that no matter how hard you try, the timeline bends around your actions. The gun misfires, you get second thoughts, a stranger intervenes, something stops you every time. Not because the universe is watching, but because consistency is its only rule. You can try to change the past, but you'll only ever do what already happened. And then there's the most mind-bending possibility of all. The moment you interfere, the universe splits. You don't change your past, you create a new one. A branching world, a new timeline, a fork that moves forward without you. You're stuck in it now, a ghost from a different history. Your original world moves on without you, unchanged, unreachable. And the more you think about it, the more the blade in your hand starts to feel like something else entirely. A test of reality's willingness to let you choose. If the thought of time resisting you gave you chills, subscribe to Early Science. We're deep in it now, and the rules are starting to bend. Some ideas don't end in mystery, they end in contradiction. The kind that doesn't just confuse, it unravels. That's what happens when you follow the grandfather problem to its final breath. Because no matter how you try to twist the outcome, it doesn't hold. You travel back. You stop the birth that leads to your existence. But if you succeed, you erase the one who took the trip. The action negates itself, a perfect loop of cancellation. A story that deletes its author mid-sentence. This is the nightmare of causality.
And unlike poetic paradoxes or theoretical folds, this one doesn't quietly loop. It explodes. Physics hates it. Logic rejects it. Yet the possibility hangs in the air because time, in all its elegance, might allow motion backward. What it doesn't seem to allow is contradiction. That's why many scientists propose a kind of narrative repair mechanism. Some call it self-consistency, others call it cosmic censorship. But the idea is the same. Events may wrap and loop, but they can't break each other. You can go back, but only to play your part in the story that already exists. Try to step off script, and the universe pulls you back. You meet your grandfather, you raise your hand, but something stops you. A coincidence, a twist, a failure. It doesn't even have to be dramatic. It just has to make the contradiction disappear. You don't get to change the past, you become part of it. This makes time travel less like control and more like choreography. You can move freely, but only along the lines already drawn. You're not breaking the story, you're fulfilling it. But if that's true, if paradoxes are simply impossible, then free will becomes paper thin. Your choices may only exist if they've already fit into some unbroken loop. There's no risk of destroying time because time already knows what you're going to do. And yet the contradiction lingers. What if there's no repair, no resistance, just a tear? One action too bold, one moment that logic can't wrap around. Then what? Does time shatter? Does a new branch grow? Or does everything just stop? If the idea of a story collapsing under the weight of its own contradiction left a crack in your own thoughts, subscribe to Early Science. Because somewhere buried in these loops and splits, there might be a deeper pattern. And maybe the reason the past feels so stable is because we haven't broken it yet.
There's a strange idea hiding behind every paradox, that the universe has standards, that it won't tolerate contradictions, that somewhere beneath the noise and chaos, there's an editor quietly deleting impossible stories before they spread. Imagine time not as a straight recording of events, but as a self-writing manuscript. The rules aren't just about gravity and light, they're about narrative stability. And when something threatens to rip the story apart, a paradox, a contradiction, a grandfather dying too early, the timeline rewrites itself, not with magic, with constraint. In physics, this idea shows up as the Novikov self-consistency principle, the concept that any event occurring in a time loop must be self-consistent. In other words, time may allow loops, but never contradictions. You can travel into the past, you can interact, but you can't change the outcome. You can only fulfill it. It's not that you can't act freely, it's that your freedom is already written into the past you're trying to change. It sounds like fate. It feels like being trapped inside a script. A character who believes he's improvising, but is actually walking the exact same lines every time. This principle has eerie implications. It suggests the past is not just resistant to change, it's immune. Try to break it, and you'll find the gun jams, or you miss, or you get stopped. Not because of magic, because of logic. Because paradoxes can't exist, and the universe has already accounted for your failure. But what if instead of editing the timeline to avoid paradox, the universe allows a split? This is where things fracture. Some models propose that a contradiction doesn't get fixed, it gets isolated. You create a new timeline, a parallel stream of reality where your impossible action plays out. The original timeline remains untouched, but you're no longer in it. You're somewhere new, alone in a version of history that was never supposed to happen, and you can never go back. So either the timeline bends around your choices, or it breaks away from them. In both cases, something is lost. The dream of absolute freedom. If this made the past feel more like a locked door than a path you can walk backward, hit subscribe to Early Science. The deeper we dive,
the more time starts to feel alive, not flowing, but thinking. And if the universe is really editing itself to avoid paradox, what happens when even the editor fails?
You take a step, simple, meaningless. But what if that step, or the hesitation before it, splits the universe in two? One version of you keeps walking, the other stops. Two timelines now branching forever. Not just a metaphor, not a narrative device, but an actual structure of the universe, sprawling, infinite, and made from decisions you didn't know mattered. This is the many worlds interpretation of quantum mechanics, and it doesn't just suggest alternate realities, it demands them. At the quantum level, particles behave like possibilities. A photon doesn't go left or right, it goes both until observed. A particle isn't in one place, it's smeared across outcomes. But when you measure it, you only see one version, one reality, one result. So what happens to the others? Many worlds says they happen too. Every outcome is real. Every possibility is realized, but not here, somewhere else. And if this applies to particles, it applies to you. To every moment you faced a choice, big or small, every word you said or swallowed, every person you met or missed, somewhere out there, you are all of them. It's a haunting kind of freedom, because now your life isn't a straight line. It's a tree endlessly branching. Your regrets are real somewhere. So are your triumphs. So are your losses. So is the you that never came to be. And when you imagine going back in time to change something, to fix a mistake, save someone, undo a decision, you're not overwriting the timeline, you're creating a fork. A new path splits off, and you're walking into it. The past remains untouched, but you can never return. This solves the problem of paradox. You can kill your grandfather in that timeline, but your original self, the one who took the trip, still came from a world where he survived. The contradiction dissolves into a detour. But now the stakes change, because every action has consequence, not just here, but everywhere. Every choice echoes into its own universe. And if that's true, then you've already created countless realities with thoughts you barely noticed, with moments you barely remember. If that realization made you feel less like a person in a story and more like the author of a cosmic library, subscribe to Early Science. The choices don't stop. The tree keeps growing. And somewhere right now, another you is wondering if you made the better choice.
Imagine waking up and feeling like something is slightly off. The room is the same. Your memories are intact. But you can't shake the feeling that a decision, maybe years ago, maybe yesterday, went differently than it should have. That sensation, that eerie dislocation, it might be nothing, or it might be the echo of a nearby reality, a version of you that chose differently and is now living a life you'll never see. In the many worlds view of reality, you are not a single thread of consciousness. You are a node, one observer among infinite versions of yourself, each riding a different branch of the quantum tree. And the strange thing is, the you that's reading this right now might not be the original, because once the universe splits, all branches are equally real. No timeline is more true than the others. They all unfold with the same weight. The only difference is, this is the version you remember. But memory is not immune. In some interpretations, even your awareness may shift slightly as reality forks. You don't notice the change. You feel continuity. Perhaps deep inside, something in you recognizes that another you made another move, and now they're watching from a different branch. Quantum computers already work with these ideas, running calculations across superposed states using entanglement to process multiple outcomes simultaneously. It's not magic, it's physics.
And it suggests the mind itself might not be a closed loop, but a spread, like a song playing across harmonics you'll never hear. And maybe that's what déjà vu is. Maybe that's what dreams are. Maybe we are constantly brushing up against the edges of the choices we didn't make. If that thought landed somewhere deep in your chest, like a memory you've never had, like a version of yourself blinking through the dark, then like the video. They're probably not the only version of you watching this right now, because you didn't just pick a path, you became one.
Take a box, seal it tight. Inside, place a cat, a small radioactive atom, a vial of poison, and a trigger mechanism. If the atom decays, the poison is released. The cat dies. If it doesn't decay, the cat lives. You don't check, you don't peek, you wait. Now, here's the question. Before you open the box, is the cat alive or dead? Logic screams one or the other, but quantum mechanics disagrees. In this setup, the atom is in a superposition, decayed and not decayed. And because the mechanism depends on that atom, the cat is now entangled with it. It too exists in a strange limbo, both alive and dead. Until you look. This is the heart of one of the most infamous thought experiments in physics. Not because it's gruesome, but because it reveals something deeply unsettling. That observation doesn't just reveal reality, it decides it. Before you observe, the cat is a quantum blur of both outcomes, alive and dead, two paths simultaneously real. But the moment you look, one becomes your reality, the other fades. But where does it go? In the many worlds view, it doesn't disappear. The moment you open the box, the universe splits. In one branch, you see a living cat. In the other, you find a corpse. Both outcomes are preserved, not just in theory, but in structure. Somewhere there is a version of you grieving. Somewhere else, there's relief. And you, the observer, are the dividing line. It's not just the cat in the box. It's every moment of uncertainty, every coin flip, every crossroad, every time you waited for the test result, the phone call, the yes or no. Each one was a branching point, a box you didn't open until it was already too late to undo. And in this world, you only get to see one outcome. But the others, they're still unfolding. If that realization made every unopened box in your life feel heavier, like the universe was whispering from the other side, like the cat never really left, then like the video. Because this isn't just a physics problem, it's a mirror. And maybe the scariest part isn't whether the cat is alive or dead. It's knowing that somewhere, it's both.
A cat in a box, a particle in a cloud, a decision unmade. In quantum mechanics, these aren't just moments of waiting. They're moments of suspension, where outcomes don't just sit side by side. They exist that way, at least until someone looks. And here's the twist that still rattles physicists. The moment of observation doesn't just reveal what's there, it finalizes it, locks it in, collapses the wave of possibilities into a single, solid fact. But what if the thing that causes the collapse is you? Not your eyes, not the device, consciousness. It's one of the most disturbing ideas buried in the foundations of physics, that the observer isn't passive. You're not just watching the universe unfold, you're a participant, a trigger. The act of witnessing decides what was real all along. Some call this the measurement problem, but calling it a problem doesn't make it go away. The equations are clear. Before measurement, particles don't have definite positions. They exist in overlapping states. Only when someone observes does a system snap into a single classical outcome. It's like reality waits for you. Not politely, not patiently, but fundamentally.
This raises a question most physicists try not to ask too loudly. What is observation? Is it just data, a sensor, or is it the presence of awareness? If the answer includes consciousness, then suddenly you, the one asking the question, become the central mechanism. You're not a background character in the universe. You're part of what builds it, collapses it, shapes it. And if you collapse the wave function, what are you doing every time you choose? Maybe you're not choosing at all. Maybe you're selecting a version of reality that already existed, and the others fall away behind you like echoes you'll never hear. If that makes your own thoughts feel like instruments, like tools of creation rather than observation, like maybe the very act of wondering carves something into the cosmos, then like the video. You're not just watching this, you're collapsing it. And maybe that's what the cat was waiting for all along. Not science, not fate, just you.
Take two particles, create them together in the same moment, under the same conditions, then separate them. One goes left, one goes right. Light years apart, entire galaxies could fit between them. And yet, measure one, and the other reacts instantly. It's not just fast, it's faster than light. Too fast for any signal to pass between them. Too fast for any message to warn the second about what just happened to the first. This is entanglement, and it might be the strangest thing quantum mechanics has ever shown us. Because once two particles are entangled, they behave like one system, no matter how far apart they are. Their properties aren't just correlated, they're connected. Change one, and the other's state is instantly determined. Einstein hated it. He called it spooky action at a distance. He believed there must be something hidden, some variable we couldn't see that explained this weird synchronicity. But every experiment said otherwise. Bell's theorem and the countless tests that followed crushed the dream of hidden variables. The universe really is non-local. Entangled particles behave as if distance doesn't exist, as if information doesn't need to travel because it was never separate to begin with. Now think about that. Two particles that used to be one, still behaving like one, across space, across time. And here's where it gets uncomfortable. Because if particles can stay linked across the void, why not systems? Why not minds? What if every interaction, every touch, every moment of shared creation leaves behind a kind of entanglement, invisible but real? What if entanglement is the rule, not the exception? Then space itself begins to feel thinner, less like a barrier, more like a surface stretched between moments that never really broke apart. You are not alone. You are never unconnected. You are part of a web older than light. And if that changed how you feel about distance, about time, about separation, about what it means to be apart, then like the video, because physics just showed us something we can't explain. And maybe what binds the universe isn't force, or mass, or charge, but memory.
Let's say you throw a book into a fire. The pages blacken, curl, and vanish into smoke. But the words, the meaning, the information isn't truly lost, not completely. In principle, if you knew every molecule of ash and air, if you could rewind every photon, you could recover it. You could reconstruct what was there. That's how physics works. Energy transforms, information persists. Nothing is truly erased. Except, what if that's not always true? Now picture a black hole. You drop something in, a book, a spaceship, a person. The event horizon swallows it. No signal escapes, no trace returns. From the outside, all you ever see is the black hole growing slightly more massive, slightly more distorted. And here's the terrifying part. According to the classical view, the information about what you dropped in, its arrangement, its story, its structure is gone. Not just unreachable, destroyed. This is the black hole information paradox. Because according to quantum theory, information must be preserved. It's the bedrock of how everything works, from the tiniest particle to the edge of the cosmos. But black holes, under general relativity, don't care. They take it, crush it, and hide it behind an invisible boundary from which nothing escapes. So which law breaks? Decades of argument followed. Some said the information is lost forever. Others said it must leak back out, encoded somehow in the radiation that black holes emit as they slowly evaporate. But no one could prove it. It's not just a question of astrophysics, it's a question of what can be known. If information can be destroyed, then so can meaning, so can memory, so can you. What if the universe has places where the rules vanish, where knowledge enters and nothing, not even the ghost of it, survives? Maybe the black hole isn't just an object. Maybe it's a boundary, the edge of reality's ability to keep its own story straight. If that made you pause, really pause, and wonder whether everything we've ever done could one day fall into silence, like the video. Because at the edge of a black hole, even truth can slip away. And maybe the most terrifying thing isn't falling into the void, but knowing that no one will ever know you were there.
A black hole evaporates slowly, relentlessly. Over eons, it radiates away mass, a whisper of heat escaping from its edges. This is Hawking radiation, predicted decades ago, still unconfirmed, still unnerving. Because if it's true, then black holes don't last forever. They fade until one day they vanish, gone without a sound. No explosion, no trace, just a slight ripple in space-time and then nothing. And here's the deepest fear. If everything that fell into it, light, matter, thought, structure, is gone too, then the universe just lost something it can never get back. A page was torn from the cosmic book and burned. This isn't just about stars and gravity. It's about the foundation of physics, unitarity. The idea that the information about a system's past is never destroyed, just transformed. The equations demand it, but the black hole seems to ignore it. Its evaporation looks clean, sterile, as if the universe itself is slowly forgetting something. And if enough of these vanish, what does the cosmos become? A place of empty silence. No structure, no record, no imprint of what once was. Not even a shadow. The black hole information paradox was never just a question of physics, it's a question of identity. If the universe can lose information, can it lose us? Some theories try to solve this, that information is stored on the event horizon like a hologram, that it's smeared into radiation as the black hole evaporates, that it's hidden in correlations too subtle to detect. But we don't know. We still don't know. And maybe we never will. Because this is where science meets something darker. The idea that reality itself may not remember everything, that some stories, entire galaxies, entire lives might fall into silence with no echo, no footprint, no way back. It makes the question bigger than survival. It becomes legacy. What do we leave behind if even the universe forgets? If that made you feel the scale of everything we're risking and everything we could become, like the video. Because some paradoxes aren't about confusion, they're about grief. And maybe the universe won't end in fire or ice, but in forgetting.
Somewhere along the line, we started believing that anything could be known. That the universe, no matter how strange or vast, would eventually give up its secrets. That science, given enough time and tools, would explain it all. But what if that belief is just another illusion? What if there are places in reality we were never meant to reach? Not because they're hidden, but because they can't be known. Every paradox we've explored, time loops,
vanishing information, superposition collapse, hints at one brutal truth. Our minds were shaped by evolution, by survival, by a need to make sense of the ordinary, not the infinite. We're built to find patterns in bird songs and faces, not to parse 12-dimensional Hilbert spaces, not to intuit a universe where one event creates two timelines or where causality flows both ways. So we reach, we model, we simulate, but we're still watching shadows on the cave wall. Reality remains behind the curtain, and every time we peek, the light burns our eyes. What if the reason these contradictions persist, these loops and disappearances and impossible decisions, is because we're trying to force logic onto something that was never logical to begin with? The universe may not be broken. Our perception might be. There's something unsettling in that thought. Not just that we don't know, but that we might never be able to know. That our questions hit a wall not of science, but of mind. That reality is too large, too recursive, too alien for brains wired for beginnings, middles, and ends. And yet we ask anyway. Maybe that's the most human thing about us. Not intelligence, not memory, but the willingness to stare into a problem that refuses to resolve and keep staring. So, if your mind feels tired, but strangely awake, like it just ran into something too big to hold, like the video. Because this series isn't about answers, it's about staring at the boundary between understanding and mystery, and the haunting possibility that beyond that boundary, there's only silence.
What if we're not late? What if we're early? We often imagine ourselves as the newcomers in a galaxy already full of ancient civilizations. The silence then becomes eerie, suspicious, a mystery to decode. But what if there's no one else to decode it? Not because they're hiding, because they were never here. In that version of the universe, we aren't just curious, we're alone. Not by accident, by chronology. Ours might be the first spark of self-awareness to ever rise from the dust, the first time the cosmos has looked inward and asked, "What am I?" That idea changes everything. Suddenly we're not explorers, we're origin points, the first voice in an empty cathedral, the first pattern of thought, the first hands to build machines that dream. And with that position comes weight, a terrifying kind of responsibility. Because if we are the first, then what we do matters more than we can possibly understand. We're shaping not just our future, but the blueprint for what intelligence can be. Our survival or our failure becomes the prologue to all consciousness that may follow, or the final chapter of something that never had a sequel. And the silence, it stops being ominous. It becomes sacred. Not a warning, but an invitation. A vast, untouched space waiting for its first story. But what kind of story will it be? A species that builds until it forgets why it began? Or one that learns, adapts, reaches, and speaks? If you've ever felt small looking up at the night sky and now feel large in a way that frightens you, like the video, because we may be standing at the beginning of something that has never happened before. And the first mind to awaken in the void has the power to shape everything that comes after.
All of this, the science, the paradoxes, the vastness, eventually circles back to something personal. About you. About the soft, temporary body sitting in front of this screen, listening, wondering. Because underneath every theory, every telescope, every machine is a mind trying to outrun something. Death. We rarely admit it, but our hunger for knowledge, our obsession with time, our need to leave something behind, it all points in the same direction. We are the only creatures, as far as we know, that fully understand we're going to end, and we don't accept it. So we imagine other timelines. We theorize about uploading consciousness.
We ask if the soul can travel through space-time. We wonder if intelligence, once born, can ever truly die. And here's where it gets strange. The same physics that suggests particles can entangle across the galaxy, that time can loop, that information can vanish into silence, also leaves room, just barely, for something beyond finality. Maybe death, like measurement, is not an end. Maybe it's a change in state. Some scientists and thinkers have speculated that consciousness could be a pattern, something that, if copied or transferred, might persist. Others imagine minds running in simulations, a digital afterlife built from code and memory, a dream that never ends because it was never tied to cells in the first place. And then there are the quieter theories, ones that say maybe this is the afterlife. Maybe the fact that you're conscious right now means you always will be, not in this body, but in a body somewhere. It's not proof, it's not comfort, but it's not nothing, because physics hasn't ruled it out and mystery hasn't gone anywhere. If that made you feel the weight of your own breath and the brief, bright moment of existing, then like the video. Because science may not give us eternity, but it gives us the tools to ask whether forever was ever ours to begin with. And maybe the desire to live forever isn't about escaping death, but about finally understanding life.
The universe is expanding. Every second, galaxies drift farther apart. Space itself stretches quietly, relentlessly. And as it does, the stars grow dimmer, the sky emptier, the night colder. It won't happen tomorrow or in 1,000,000 years, but someday the lights will go out. The last stars will burn through their fuel, the last black holes will evaporate, matter will decay. And what's left won't be silence, but stillness, absolute stillness. No warmth, no motion, no thought, just cold. This is the long view, the heat death of the universe. A future where entropy wins, where everything useful, everything structured, everything alive dissolves. But here's the paradox. If it all ends in nothing, then why did anything begin? Why emerge from that stillness, only to return? Why produce consciousness, only to watch it vanish? Why spend billions of years assembling stars, molecules, minds, for a story that ends with a blank page? Some say the universe doesn't care. It has no reason, no plan. It simply is. Others wonder if this echo, this final stillness, is part of something larger. Maybe entropy isn't death. Maybe it's reset, a coiling spring before another beginning, a deep breath before another big bang. Or maybe this is the only round, and the echo we're hearing isn't from the end. It's from us. Our questions, our hopes, our attempts to write meaning into a system that never asked to be understood. Maybe the echo isn't from the edge of time, but from our own need to matter. In a universe that keeps whispering back, "You are temporary." Still, we listen. If you've ever stared into the night and felt it staring back, not coldly, not cruelly, just blankly. Because sometimes science doesn't answer the question. It is the question. And maybe the echo at the end of time is the sound of something that once dared to care. We've talked about black holes in time loops, multiverses and information loss, cats that are dead and alive, observers who shape reality, machines that learn to think. But beneath all of it, every contradiction, every mystery, something has been quietly watching you. Not as a bystander, not as a narrator, as the paradox itself. Because here you are, aware, wondering, temporary, infinite, a creature built from dust asking questions no stone ever asked. You contain atoms that came from stars that died before Earth was born. You think in language that evolved from grunts and firelight. You imagine your own end, and you keep going. That shouldn't be possible. You're built from parts that don't care about you. Blind molecules, mindless energy, systems that follow rules, not dreams. And yet somehow, from all of that, you emerged. Not just breathing, thinking. And here's the cruel wonder. No matter how far science stretches, no matter how many dimensions we unfold, how many timelines we map, how many equations we balance, the thing we understand least is the one asking the questions. What are you? A signal riding a nervous system? A flash of organized matter? A glitch in biology? Or are you the universe's answer to its own silence? We'll never know for sure because every answer folds back in on itself. Every path loops, every truth becomes a mirror. You are not outside the mystery, you are inside it. And maybe that's what all of this has been about. Not to solve the paradoxes, to realize that you are one, a mind that can't explain itself, a being aware of its own disappearance, a voice echoing through a universe that may never reply, and still you ask. If that thought left you still, not with fear, but with wonder, like the video, not because you have the answers, but because you're willing to keep listening. Because maybe the last paradox isn't out there in space or time, maybe it's here, now, the impossibility of you. And that's where the story ends, or maybe where it begins.